Hello, Zikra.
Hello, ma'am.
Good evening. Yeah. So please switch on your camera. Zikra, this is your first class, right?
Yes, ma'am.
Yeah. Zikra, switch on your video.
Sorry, ma'am. I can't.
Why you can't?
That's a network issue, then.
Okay, network issue. Okay. So nobody join. Let me give you the some. See, that day you was not there in the class, right?
Yes, ma'am.
Yeah. So see, now what is matter? Do you know what is matter?
Yes, ma'am.
What?
Ma'am, anything that occupies in the space and has a mass is called matter.
Hello,
And I came late.
it's okay. Hello. So Arham, what is matter?
Matter is just something that is like physical, like a solid, liquid, or like a gas.
Good evening, ma'am.
It's like matter is like everything that you can touch or feel. It's like earth, like that.
Anything that occupies a space and has mass.
Has mass.
Yes.
It's like this
Right.
kind of matter.
Arham, air is matter or not?
Air is matter.
Very
It occupies space and it has mass.
Hello, Advika.
Hi, ma'am. Excuse me, ma'am.
Yeah,
Ma'am, today, ma'am, is it okay if I leave the class around 6:30?
What?
Ma'am, 1 second.
Please switch on your camera, guys. Habib and
Ma'am, I'm out somewhere. I cannot touch my camera.
Oh, you can't. Okay, Advika, you see. This is the three states of matter: solid, liquid, and gas. Right?
Yeah.
Ma'am, even I'm not at home. Ma'am, I'm not at home right now. Ma'am, I'm out of house. I'm out of my house.
Will you please message your voice is not coming?
Ma'am, can you hear me?
Yeah.
Ma'am, is that was better now?
Yes.
Ma'am, I was just saying that I'm not at home right now. I'm in my car, so that's why I can't turn on my camera. Ma'am, is it okay if I leave class around 6:30 today?
Okay. Thank you.
Ma'am, I'm actually traveling.
Huh?
Ma'am, I'm actually traveling. That's why.
Okay, no issue. So today we will be learning about the latent heat. Okay, what is latent heat? Okay, but let me ask you the very important question of this chapter. So when a solid melts, its temperature remains the same. Why?
Yeah.
See, if this is my solid, if the solid is melting, my temperature remains same. Why? Anyone?
Ma'am, because the air is providing it with heat.
Because it's trying to match the outer temperature, so it's heating up.
Yeah, kind of. Yes, I know. See,
It's because of the energy of like that, they are moving very fast. So
hello, Sharia. Please
become,
switch on
it
the cameras.
wants to become the same temperature as the outside. So that's why it's becoming like that. It becomes hotter and then it melts.
It should increase 1 or 2 degree, right?
Yeah.
But when it is melting, the phase of melting will consist of only 0 degree.
Yes.
It's not increasing 1 degree, no, 2 degree, no.
Yes.
0 degree Celsius is melting point only for ice, not all solids.
Not all stuff.
Yes. So this is the phenomena of the latent heat, and now we will be discussing about the latent heat, that why the temperature remains same, why the temperature is not increasing like 2 degree, 3 degree. Okay. Next. Now let's start. Let's take this example. This is my beaker and
Excuse me, ma'am. Can you explain it again?
okay. See, this is my question, that why in the melting phase temperature remains same? Why my temperature is not increasing as 1 degree or 2 degree? After melting it will increase, but in the phase of melting it's not increasing. Got it?
Yes.
So this, now we will be discussing this thing. For example, I'm heating this my beaker. Okay, heating, and let's say here is my 30 degrees Celsius. After 30 degrees Celsius it will increase, right? Because we are giving heat. If you will give heat to anything, its temperature will increase.
Yes.
Correct? Yes.
Yes.
But up to 100
Yes,
degree, but up to 100 degree only the temperature will increase.
Yeah. Because after that it starts to boil.
See, sorry. Let's say this is my 100 degrees Celsius. 100 degrees Celsius. But up to 100 degree it will show on thermometer, because 100 degrees is the boiling point of what? Of water, no?
Water.
Yes, water. Good. Boiling point of water. In 100 degrees Celsius, it will change. Why? Do you know why? After 100 degree, it will remain same. It will not increase like 110, 120, but from 30 to 100, it will increase. After 100, it will not increase. Why? Anyone? Okay, let me explain. See, after 100 degrees Celsius, it will change its phase from liquid to gas. Yes. Liquid to gas. See, this is my liquid, all the intermolecular forces, and this is my gas.
Oh.
They are apart from each other.
Yes.
It needs some energy for conversion, because without energy, no one can break the force and keep them apart. It needs some energy for what? For conversion. Conversion from liquid to gas. Without energy, no one can break, right? No one can break its what? No one can break the force. So we need to break intermolecular force of attraction. For that, we need energy. So that energy is called the latent heat. Let me write here. See, this is the conversion going on from the from the liquid to gas conversion, because without energy, no one can what? Break the force.
Force of attraction.
Yes, very good. We need to break the intermolecular force of attraction. We need to break intermolecular. Arham, got it? I will explain
Yes.
intermolecular force
Yes,
of
ma'am.
attraction. For that, we need energy. And that energy is called latent heat. What is latent? What is the like meaning of latent? Anyone? Zikra, you, Sharia, what is the meaning of latent? Arham? Sorry, your voice is not audible. If it's possible, please switch on your cameras. Sharia. Okay, so latent means hidden. This is a kind of hidden heat. है ना? Because liquid to gas, my conversion is going on, because without energy, no one can break the force from the liquid to the solid, and we need to break the intermolecular force of attraction, because we are converging from the liquid to solid, and for that we need a latent heat. That's why after 100 degrees Celsius, my temperature will not increase. It will remain constant, because this is also a boiling point of temperature. Everyone got it? Any doubt in this?
No, ma'am.
No doubt? Sure?
Yes.
Yes?
Yes,
Okay.
ma'am.
So here also same thing will apply, because at the time of why temperature remains same here? Same logic. Why? Anyone?
And latent heat?
Yeah, latent heat. Very good. Latent heat, because it's busy in the intermolecular force of attraction. So here also latent heat. Sorry. The logic of latent heat will come
Yes, ma'am.
because of latent heat. Everyone got it?
Yes, ma'am.
Now, yes. Any doubt? No doubt.
No doubts.
Okay. Boiling point of water is 100 degrees Celsius. After 100 degree, temperature will remain same, because that heat is now helping in the intermolecular force of attraction to break. Got it? Correct?
Yes, ma'am.
Now, can you please explain it again? Who? Sharia. Sharia, what's the doubt? Which part? Arham, you understand? Arham, can you explain? Arham, can you explain?
I understand it, but like
Like what? Okay. You, Arisha, Habib, like, can you explain?
Ma'am, it's Miss Shazan. Joined from another account.
Shazan, okay. How was your day, Shazan?
I'm at a fine.
It was good? Okay. So, Shazan, can you explain?
I'm what to explain here?
Huh?
What to explain? There's nothing to explain here.
Yeah, that's what, Sharia. There's nothing to explain. Okay, explain Sharia. Come on, Shazan, explain Sharia. That what is latent heat?
Latent is it, like conversion of liquid state to like gas. Wait.
Here we need to break the intermolecular force of attraction.
Force of attraction.
And for that we need energy. That energy is called the latent heat. Means the hidden heat. Correct? Sharia, you understood? Okay, now you explain me. What is latent heat?
Ma'am, we can also say that energy absorbed or released by a substance during a change in its physical state that occurs without changing its temperature.
Yeah, you can also say this, kind of. Yes. So now, Sharia, will you explain? Sharia, your voice is not. Will you explain what is latent heat? No. Okay. So, see here, what is this? Okay, let me do this. First, let me explain. Just a minute. Say, let's say this is. Let's say I have a solid and temperature is 80 degrees Celsius. Okay, let's say this solid and temperature is 80 degrees Celsius and melting point is 500. Okay, melting point is 500 degrees Celsius. And if we supply heat, temperature will increase or decrease. Sharia, you are not understanding anything and you are not switching your camera also. So it's very bad. Okay. Arham, what will happen if we will heat 80 degrees Celsius? Temperature will increase or decrease?
it will. I think it will
80 to 500. The temperature will increase or decrease?
increase.
Can I answer?
Yeah, Zikra, sure. You can anytime.
It will increase.
Yes, good. It will increase.
Yeah.
Solid and 500 degrees Celsius. Let's say I have this 80 degree, this solid, and temperature is 80 degree, and if we supply heat, temperature will increase. Temperature will increase only up to 500 degrees Celsius. This is my solid. This is
After
my.
that, ma'am? After 500 degrees Celsius?
After 500 degrees Celsius, temperature will not increase. Temperature will remain constant because my.
What if we try to increase it then? What if we try to increase it and it get increased? So what will happen? Plasma state.
Only temperature will increase on up to 500 degrees Celsius only, na? Because my melting point is 500 degrees Celsius. It will increase only up to that. After that, it will not increase because conversion will happen. The same logic will apply here also. This logic conversion, because conversion from solid to liquid. See here, conversion is from liquid to gas, and here the conversion will from solid to liquid. The conversion is happening. The intermolecular conversion because
Understood.
no one can break the force. Intermolecular force of attraction, latent heat. Yes, got it? Any doubt?
Yes, ma'am, got it. No, ma'am, no.
Good, very good. Adam, got it, Adam?
Yes, ma'am, you are saying that the maximum temperature a solid can reach is 400 degrees Celsius.
What, Shazan?
Yes,
Your
ma'am.
voice is breaking.
No, means you're saying that means a solid can only means resist the temperature to 400 degrees Celsius.
Your voice. Can you please type? Okay.
Okay,
Now,
I'll type.
Sharia, you got it? Sharia, now you tell me why temperature is not increasing after 500 degrees Celsius. Come on. Sharia means you are not attentive to the class. You are not switching your camera also. And you are
ma'am.
Yeah.
Vika, ma'am, can you explain ma'am, can you explain this concept again?
Which?
Ma'am, ma'am, this one, ma'am, the one we just did. Ma'am, the latent heat, but in liquid to gas.
Okay. What's happening? Nothing is happening in my. Just a second. This part.
Yes, ma'am.
See, here what is happening? The boiling point of water is what? 100 degrees Celsius.
100 degrees Celsius.
Yes. So, after 100 degrees Celsius, why my temperature is not increasing? Because it will convert from liquid to gas, right? Conversion, because without energy, no one can break the force.
Yes, ma'am.
Charya, your voice is not clear. You are not switching your camera, not even your mic, so it's not. Now, we need to break the intermolecular force of attraction. See, liquid and then gas. In liquid, we have some forces, and in gas, we have some intermolecular forces. So to break that, we need intermolecular force of attraction. So my heat is doing that thing. That's why my heat is not, increasing after 100, because my heat is working. My heat is helping this part to convert from liquid to gas, because it's a latent heat, and heat is not applying there to increase the 100 degrees. Got it, Arpita? Or again also doubt? Shazan, you got?
Ma'am, I understood. Ma'am, I understood now.
Because heat is applying here. That's why heat is not increasing here. Heat is.
Ma'am, okay, ma'am, and then for the temperature that it can't go more than 500 is because then you require a lot of energy, and it's not possible to break the intermolecular bonds at that point.
Yes. For that, my energy is breaking the intermolecular force of attraction. That heat. So that is called the latent heat. Here only up to 100. After that, energy is doing this work, is converting from this phase to that phase, because for this we need a very high. Okay.
Okay.
Yes,
Again, doubt? Any doubt? Anyone? Zikra? You?
No, ma'am.
No? Okay. Now latent heat of fusion. Where is it? Here. What is latent heat of fusion? Anyone?
I don't think I know.
See, amount of heat required to convert 1 kg of a given solid into liquid. For example, let me draw a latent heat of fusion. For example, this is my solid, and this is also my solid. Okay, solid and solid. 1 kg and 1 kg. Now heat them. Okay, and convert it into liquid. The heat which involves in the conversion. Now, if we will heat them, and we will convert it into a liquid. For example, we are heating. Okay, and we are converting it into the liquid. The heat which involves in the conversion, that is known as latent heat of fusion. If we apply heat and my solid phase will become a liquid, that heat is known as latent heat of fusion. Solid to liquid. Adham, got it? What?
Can you explain again?
Yes. See, this is my solid, huh? If I'm heating this,
Okay.
if I'm heating this, and if this solid becomes liquid after conversion, then that heat is known as latent heat of fusion. From solid to liquid, that heating phase is known as the latent heat of fusion. Got it, Zikra?
Yes, ma'am.
What is latent heat of fusion?
Ma'am, when solid is heat and is converted into liquid, then
Yes.
the heat of fuel.
That full phase, that full process is known as latent heat of fusion, when my solid is converting into a liquid. Very easy, है ना? Shazan, Advika, Arham,
Yeah, I understood.
what you understood? Now you explain. Arham, your mic is off.
Sorry, I said that I understand it. Like when a solid turns into liquid, it's
When
called
we heat solid, and when we heat solid, and when solid will convert it into liquid.
The process is called latent heat of fusion.
That process is known as the latent heat of. Shazan and Advika, and you, Sharia,
Yes, ma'am, got it.
got it easy?
Ma'am.
Yeah.
Advika, you? And what is latent heat of vaporization? Any idea? See, it's written also.
I think it is when
Mhm.
it turns into gas.
Yes, very good. When liquid turns into gas, amount of heat required to convert 1 kg of liquid into gas. Yes, very good, Adham. And what about you, Sharia? Sharia, you got it? Sharia, amount of heat required to convert what, Adham?
Liquid.
1 kg of liquid to gas.
Yes, 1
liquid
kg of
gas.
1 kg of. Very good, Shazan. 1 kg of to gas. That is known as latent heat of vaporization.
Latent heat of vaporization.
And from solid to liquid is known as latent heat of fusion.
Latent heat of fusion.
Yes, very good. Got it, everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good. Now let me explain the evaporation. What is evaporation?
Ma'am, conversion of liquid to gas is another evaporation.
Conversion from?
Liquid to gas.
To gas.
Yes, conversion from liquid to gas. See, here is my boiling and here is my evaporation. See, boiling is what? Liquid to gas. Evaporation is also liquid to gas. है ना? Both conversion is similar to. हाँ.
Now is the boiling point and melting point the same for liquids?
Huh?
Now the boiling point and melting point for all for like the liquids is the same, right?
Your voice. Will you please message me?
Ma'am, can you hear me?
Yeah, but it's breaking.
Ma'am, 1 second.
You can type.
Is it better now? Is it better now?
You're on. Tell what?
Ma'am, like for liquids like in water, is the melting point always the same as the boiling point?
What is what? Please type, Asika.
Yes, ma'am, I'll type it.
Please. Now, what is boiling? The phenomena of conversion of liquid to gas at its boiling point. And what is evaporation? The phenomena of conversion of liquid to gas at any temperature. Let me explain. See, here is what? The phenomenon. Let me write this the short form. The phenomena of conversion.
Conversion of liquid to gas at its boiling temperature.
Yes, from liquid to gas
Yes.
at its boiling temperature. And what is boiling point?
100 degrees Celsius for water.
100 degrees Celsius of water. And what is this? Evaporation? The same thing, but at
Conversion of liquid to gas at any temperature.
any temperature.
Ma'am, I put my question in the chat.
Okay. Conversion of liquid to gas at any temperature. Aram, you got it? What is this?
Yes.
This is at any temperature and this is at only boiling.
100 degrees.
Yes, 100 degrees. Let me see the question of ma'am, it's the melting point in liquid. Melting point liquid always the same as the boiling point. Melting point in liquid is as same as the boiling point. Adham will answer. Adham, come on, answer this question.
I don't think so because
Why do you think so?
point is I think it is
Okay, now Shazan will
I'm
answer.
just asking about liquids in general because like for water it's the same.
What's the question?
Okay, Shazan, you answer.
What's the question?
Melting point in liquid is always the same as the boiling point.
No, ma'am.
How?
Ma'am, because melting point is 100 degrees Celsius.
And what is
And
boiling?
boiling point is not the same for every liquid.
For every liquid means?
I'm like boiling point is 100 degrees Celsius for water only.
So
Yeah.
So it's liquid. Let's say it's water. Now it will be same. What, Shazan? It's same, right? Adham, Shazan.
Yeah, just the same.
It's just the same. Okay, it's just the same. Now, this part you got it? Advika, this part you got it? That in the boiling point,
Yes, ma'am.
the conversion of liquid to gas at only this temperature. But here at any temperature.
Oh, any
At
temperature.
any temperature. Okay. This is
Yes.
only the difference between the evaporation and boiling because both are the conversion from liquid to gas only. This is at 100 and this is at any.
At 100. Okay.
At any, yes. Now, what's the next difference between evaporation and boiling point? This is my boiling, no? This is my boiling.
Ma'am, boiling takes place while heating.
What?
Ma'am, boiling takes place when we heat a liquid.
What?
Ma'am, yours, okay.
No, I'm asking what? Like your voice is.
Excuse me, ma'am. Ma'am, this is Abhita. Can I leave the class?
What?
Ma'am, can I leave the class now?
Oh, yeah. Okay, thank you. I will send you the recording. You can go through that, okay? Thank you. Bye. Now, boiling is having a bulk phenomena. What is bulk phenomena? Means all particles are involved in this. In boiling point, what happened? If we heat a this is my boiling. Sorry. This is my evaporation. Here it will be bulk phenomena. If we heat if we heat a water, what will happen? The bubbling happens, right?
Yeah, bubbling happens.
The bubbling happens. That's why it is a bulk phenomenon. Okay. And in evaporation, the surface phenomena is here. Surface.
It does not produce any bubble.
Surface phenomena means only particles of surface are involved. Surface phenomena means only particles of
Surface.
surface are involved. And this boiling point is energetic process. Am I correct, Aram? It's energetic process.
Yes.
Yes, because bubbling and all is happening, right? So it's very energetic, है ना? Bubbling process, and this is what gradual process. Shazan, you got it? Zikra?
Yes, ma'am.
Yes, this is an energetic process, and this is
Gradual process.
yes, and this one
Yes,
is having a bulk phenomena because bubbling is happening if we are heating a what? If we are heating a liquid.
Liquid, and in evaporation there is surface phenomenon.
Surface phenomena. Very good. And you, where's this? Sharia, what about you? You got it? Sharia, my voice is audible to you or not? Yes, you can switch on your cameras. Come on, switch it on. What do you mean? Come on, switch it on. Let me see.
Camera's on.
What, Arham?
I'm saying my camera's on.
Yes, your camera is on. I'm asking Sharia to on. Why you can't? Sharia, you are not answering to my any question, and this thing will not happen in class. You have to be interactive with teachers. This is not the way. So what is evaporation? It causes cooling. Can I say?
Yes.
Yes, it causes cooling. Okay,
Yes.
let me ask you a question. Just a minute. When there is a sweat in our body, we feel cool, right?
Yes.
Yes. Why we feel?
Because what happens is our bodies produce skin on our water on our on our bodies. So when the heat comes, it evaporates the water.
Wow, Aram, very good. Yes. For evaporation, we need to break the force, and for breaking it, we need energy. Means heat. So it will take my body heat to break the force.
Yes.
So sweat is a cooling system of my body. है ना?
Yes.
Let me see. This is my question. That, for example, this is my body. Okay, and here this sweat, these small particles. This sweat is here. So sweat in my body feels cool. Why? Because for evaporation. Because for evaporation, we need what? We need to break the force.
Force of attraction between the molecules.
Correct. And for breaking, we need what, Arham?
For breaking force, we need heat.
Yes, energy.
Yes.
Means heat, है ना? So it will take my body heat. So it will take my body heat. It means heat withdrawn from my body. That's why we feel cool. See here, this is my body. Okay, this is my body. This is my face. This is my body. And in body, this is heat. And now evaporation takes my body heat to break the force. Evaporation is taking my body heat to break the force, right? Now that's why we feel cool. Sweat is a cooling system of my body because evaporate leads to cooling. Evaporate leads to what? Cooling. Anyone any doubt? Because this is the very simple logic, है ना? For evaporation, we need to break the force, and it will take. And for breaking, we need energy. From where it will take energy? It will take energy. It will take some energy from the surrounding. It will take a maximum amount of energy from my body. That's why we feel cool in sweating. Shazan and Zikra, you got it?
Yes,
Yeah.
ma'am.
Yes, ma'am. Can you explain it again for
Yes.
better understanding?
I'll explain it again. See, Arun, can you explain?
Yeah.
Yes, go ahead.
So what happens is when sweat produces, it creates tiny drops of water on your body. And what happens then? So it will take the heat mostly from the body and it will evaporate. So it will make your body less hot. It will
Yes.
make it colder. So
Ah,
that's what's happening.
Yes. Shazan, now? Shazan, you got
Yes, ma'am. Understood.
No,
Yeah, I got
for evaporation, it's taking my body heat, my energy to break the force. So it's taking my body heat. So when heat will go
Ma'am,
up,
I have a question. Ma'am, does evaporation also happens while cooling?
evaporation, what? Evaporation
While
leads to
cooling.
cooling. Evaporation
While cooling.
while cooling? No, while cooling, no. Evaporation leads to cooling. Evaporation. Zikra, now you understand why you feel cool when there's a sweat in your body?
Ma'am, I have a doubt. Not in this, I just had a question.
Hmm.
If you seal a syringe and if you put some water inside and seal a syringe and pull, will it evaporate or will it boil?
What? Come again?
If you put some water in a syringe and put an airtight cap on it and then pull it, will it evaporate or will it boil?
Evaporate or boil?
Yeah, because I have tried one thing where I put some water in a syringe and I put it with an airtight seal. Then when I pull the syringe, it becomes into a gas. So I don't know.
It will evaporate.
Oh, okay.
Yes, it will evaporate. Now let me. Okay, see, this is also now. See, factors affecting the rate of evaporation. Can you tell me what are the factors affecting the rate of evaporation?
There is heat,
Temperature.
temperature.
Yes.
Temperature. There's how much liquid, how much water. Does that also affect?
What?
How much water is there? 200 milliliters of fire.
Humidity.
What?
humidity.
Oh, yeah, humidity.
है ना?
Yeah, and also does it
And surface area occupies with the
Yes, very good, Zikra. Surface area, temperature, and here let's say my rate of evaporation.
and also does it also depend on how much liquid is it?
How much speed? Wind speed.
and wind speed.
Yes.
Yeah.
Yes. If temperature will increase, my rate of evaporation will increase or not?
And it will decrease.
It will?
Sorry, it will increase.
What, Sharia? Sharia, what? Okay. What, Shazan? Temperature will increase, so rate of evaporation will increase or decrease.
I think it will increase.
How
Yes,
it will?
ma'am.
If temperature will increase, then rate of evaporation will increase or decrease.
Ma'am, increase, most likely to increase.
But why?
Ma'am, because the temperature is increasing and it is heating the substance and it is breaking the force of attraction between them.
Yes, very good. Now you got the concept. When temperature will increase, rate of evaporation will increase. For example, my dress is drying in the in my garden, and if sunlight temperature is very much, then what will happen?
Your clothes will dry faster.
Yes, that's why if rate of evaporation will be more, if temperature will be more, then my rate of evaporation.
Rate of eruption will be more.
Yes. And what about this wind speed?
Wind speed. If wind speed increases, that means that evaporation also increases.
Yes.
Because what happens is the
Take
air
same
rises
take-
and then the wind just blows it, so more air can rise.
Take the same example of dress, Aram.
Yeah. So
If there is more wind.
There'll be more wind, so it will cool off faster also. Because what happened, the temperature, like it will evaporate, but then there'll be wind, so it will just blow it away. So it doesn't keep on keeping that.
Yes. Shazan, correct now?
Yes, ma'am.
And what about surface area?
Surface area is like how much water is exposed. So if there's a little water exposed, only less evaporation can happen.
So surface area will increase, then rate of evaporation will increase.
Will increase.
Yes, will
Because
increase.
there's more.
Yeah, because if dress is my far apart from each other, then it will dry quickly and easily.
Yeah.
Yes. Yes. Now, last question. What about humidity? If humidity will increase, then what happens?
Ma'am, I don't know what is humidity.
What?
I don't know what is humidity.
You don't know what is humidity?
Yeah.
Zikra, what is humidity?
The climate.
The climate like what? Okay, Sharia, the climate like what? What is the meaning of the humidity?
Is it like how much water is already in the air?
Yes. I don't know. Okay.
So
Shazan, what is humidity?
Ma'am, humidity is the amount of precipitation. No. Water molecules present in air, I think.
Water molecule is present. है ना? So if humidity will increase, my rate of temperature will increase or decrease.
I think it will decrease.
Very
It will increase.
Sharia, wrong. Aram is correct. Aram, it will decrease. Very, very good, Aram. Very good. It will decrease. Why it will decrease? Because if in air there is already a water, then the rate of temperature will be, then the rate of evaporation will be less.
Yeah.
है ना? Because in air it's already a water, then the rate of evaporation will be less. Sharia, you got it? Everywhere
Yes.
it will not increase, it will decrease also. Okay, Sharia? Yes.
Okay.
Yes. If in air. Sharia, now your network is okay, I guess. So now you can switch on your camera.
Ma'am, I have some issue on my camera.
Issue on your camera. Okay. If in air there is already a what? Aram, already a?
If there's in air, there's already air molecules.
Water.
Yeah, water molecules. Sorry.
Water molecules or air water, then the rate of evaporation will be less. है ना?
Yes.
Shazan and Zikra. Now let
Yes,
me ask you guys the questions. Why drops on bottle after removing from fridge? Why this happens?
That happens because the water.
Ma'am, because the temperature is increasing now, sir. So it's melting.
Can I tell?
Water na?
Can I tell? What happens is the water molecules just like evaporate and stick to the bottle, and also they stick to
Or
themselves.
simply evaporation, ma'am. Evaporation.
A small
Yes,
bubble.
simply evaporation. Yeah.
Just
So what happens? In atmosphere there is a water vapor.
Yes.
है ना? So this cool source is cooling their surrounding, and in surrounding gas is also present.
Yeah.
है ना? So see now let me color. So what happens? Gas and then cool. So what will happen? Condensation.
Yeah.
Condensation means liquid. That's why you see a drop.
Yes. And I think there's some type of effect or something that makes them stick to the bottle and stick together.
After condensation of gas, it becomes liquid.
Liquids. I mean liquid.
है ना? Now what about this? Why do we wear cotton clothes in summer? Why not the woolen types of clothes? Why cotton clothes?
Because I think cotton doesn't like keep heat with itself. Like woolen clothes is like it will keep it
Like
it's surrounded, so it'll feel warmer, just like a blanket.
Shazan, yes, Aram, yes. Shazan, why?
And cotton clothes will not do that.
It's not?
So it'll actually feel cool.
Why do we wear this cotton clothes in summer? Why not the woolen clothes?
Mm,
Because cotton cloth can absorb my sweat easily.
yeah.
है ना? So if it will absorb my sweat easily, then evaporation will, then same thing is happening here also. See, where's that? Here. No, not here. Here. See, cotton cloth absorb my sweat easily. So if my sweat is absorbed in my body, so evaporation need to break the force, and for breaking the force it needs energy. So evaporation will take my body energy to break the force. So that's why we feel cool in the in the cotton clothes
And cotton
as compared to woolen clothes.
Yes.
And that's why blankets are also made from. That's why blankets are also made from also.
Zikra, you got it? Same
हाँ.
theory will apply here of this body sweat and this cotton clothes. है ना? Absorb my sweat. The let's say this is my cotton cloth, and this is my sweat. Absorbed sweat. So it will easy
It will easily absorb. It will easily absorb it.
it will easy evaporate.
Sorry, evaporate.
It will easy, है ना?
Yes.
Got it? If cotton clothes is absorbing my sweat, then you guys can apply this logic. If sweat is there in my body, then it will take a force to break, and for energy, it will take my body energy to break. That's why we feel cool.
Yes.
Okay, Aram, Zikra, Sharia, and Shazan.
Yes, ma'am.
Shazan, any doubt? Very easy concept.
Yeah, no doubts. Yeah, it was very easy.
Yes. And you, Sharia? No answer. Okay, Sharia is busy in something else. Let it be. Now, see, this is what? This is sanitizer.
Yes.
Sanitizer also feels cold if we pour it in our hand.
Yeah, I did notice that when sometimes pour too much. I think it's because of the alcohol.
Because of alcohol?
No, sorry, something else. I don't remember it.
Because it is more volatile. And volatile means it will evaporate fastly.
Yeah, alcohol is how it works.
If sanitizer we are pouring in our hand, then it is more volatile, means it will evaporate fastly. If something is evaporating fastly, then my this skin will feel cool. है ना? Then the water is not volatile. Sanitizer is more volatile because it will evaporate fastly. So if anything is evaporating fastly from my body, then we will feel cool. Correct? Can you guys relate?
Yeah. Yeah.
Aram,
When
why?
we too much hand sanitizer, it felt cold
Why? Because
it was easy to evaporate.
it is more volatile. More volatile means Shazan?
More volatile means it can evaporate more quickly.
It will evaporate fastly.
Yeah.
So if anything is evaporating fastly, we will feel cool. Water is not volatile. If we are washing our hand with water, so we won't feel cool, right?
Yeah.
Because water is not volatile. Yes, Zikra? Yes, you got it. Why sanitizer feels cool?
Yes, ma'am, because when we spray it, it evaporates rapidly.
And when something is evaporating, then cooling effect will happen to
Then
our
cooling effect happens.
Yes. Any doubt? This concept is clear, right? The evaporation
Yeah,
concept.
ma'am.
Yes.
Yeah.
It's totally clear.
Shazan, no?
No, ma'am, no doubts.
Okay, no doubts. Okay. Chalo. This thing is done.
Yes.
Sanitizer thing is done. Cotton clothes done. This thing done. And factors affecting temperature, wind speed, surface speed, and humidity. Aram, what is humidity?
Humidity is how much like water is there.
Yeah. In the surrounding. Huh? And this thing also done. Why we feel cool?
Yes.
Because of evaporation.
And also the difference between evaporation and boiling.
What?
And you told about the difference between evaporation and boiling.
Yes. This is the difference between the evaporation and boiling. Boiling, the phenomenon of conversion from liquid to gas at boiling temperature, means at only 100 degrees Celsius.
But evaporation can have at any degrees.
At any temperature. This is bulk phenomena because when we heat a liquid, it will boil.
And for evaporation, the surface phenomena.
Surface area. And this is when something will boil, it will become more energy.
Yeah.
So energetic process. And
Energetic process and their gradual process.
Good. I'm good. So this thing is clear. Sanitizer more volatile, evaporate fastly because
it evaporates more fastly because it will feel
it will take my body heat.
It will take body heat and
yes, very good. Now only the last topic remains. This plasma. It's already 6:54.
Oh, I know about plasma. It's like something like there's solid liquid and gas, and if you heat gas up, it becomes plasma.
What? Come again?
Like if you heat a solid, it'll become a liquid. And if you heat a liquid, it will become a gas. If you heat a gas, it will become plasma.
Is it so?
Yeah.
No, okay. Okay, we will talk this thing about in the next year. This is the last topic of this chapter. Shazan, this chapter is
Yes,
over
ma'am.
in your school?
Which is no, I'm not over.
Not
Yeah.
over.
And
Okay.
plasma is actually so hot that the like everything just
Ma'am,
starts.
this last topic is like, no, sorry, ma'am.
What, Shazan?
And this is the last topic.
Yes, this is the last topic.
No, I'm just cover it now.
Huh?
Cover it today only.
What?
Ma'am, cover it today only. More better.
Cover today only because it's already 6:55 now. Then everything will be like.
And I also have to go like outside at 7.
So got it, na? Today what we have learned about the last diagram is remaining, na? Let me clear this. See here, here energy. This is very important diagram. Energy is increasing. If temperature is increasing, then my energy is
Energy increasing
yes.
because energy is actually the temperature.
Yes, sir. Yes. Now this thing. No.
That-
Sorry, the line and this and this thing and this thing. Okay.
Yeah.
Now here, this thing is my solid, and if we will melt solid, this melting phase is going on. It will become, for example, we are melting solid at 500 degrees Celsius. If we will melt solid, it will become
liquid.
it will become liquid.
And then if you melt liquid, it will become a gas. I mean, if you boil liquid, it will become gas.
Yes, but this thing is wrong. I'm sorry. It should be like this thing and this thing.
Oh yeah.
Liquid.
Yeah.
Anyone? And now the vaporization thing will happen.
And then it will become a gas.
Then it will become a gas. At this thing, this temperature is 500 degrees Celsius.
Mhm.
So these two thing is called as the latent heat. And what is latent heat?
Latent heat is like when you boil something, if the temperature stays.
Temperature stays. Yes. And why temperature stays? Because heat is busy in doing some another thing. And what's that? Breaking the intermolecular force. Another.
Ma'am, what are you discussing this, ma'am?
What?
Summary. Is it summary?
What?
Ma'am, what are you discussing right now? I'm asking.
Summary.
What? I don't what?
Nothing. There's nothing. Anything.
Shazan, I'm just discussing what is latent heat. Okay? Latent heat.
Okay.
Yes. Shazan, will you please explain just for the last time what is latent heat?
Yes, ma'am, I'll explain.
Explain it. Explain.
Yes, ma'am, 2 minutes, I'm reading it.
You are doing what?
Ma'am,
Oh.
ma'am, okay. Latent heat is energy
Hmm.
absorbed by and released by a substance
Hmm.
when during a change in its physical phase without changing its temperature.
Because we need to break intermolecular. We need to
There
break
are two
it.
types of latent heat of vaporization, latent heat of fusion.
Yes. Correct. So got it. Everything. Evaporation got it. This is the very interesting. No, the sanitizer wala thing.
Yeah.
Yes, ma'am.
Yes, because more volatile. Evaporate easily. It will take my body heat. So that's why it's cool. Now the last topic is fusion. The plasma. I'll explain it in the next class. Okay. So thank you everybody. Thank you.